Alright, so we're on number 4 now, and we're going to go back to field goal attempts and field goals made. So remember, if we're not into basketball, these are basically shots taken, and field goals made is basically just shots made. And it says, in lesson 9.1, Zumi collected basketball statistics and created a scatter plot below comparing the number of field goals made and field goals attempted. And you can see it's kind of a positive correlation. It's going up. So I want us to draw a best fit line here as well. Let's go ahead and draw a best fit line. And it would look something like this. So remember, be careful. You don't want it too high or too low. You want to hit as many in the cluster. So this is the most where they are. You want to draw it going through the majority of the cluster and something about like that. So you're hitting a lot in the cluster, and then you have a few above it, but you also have these below it that are pulling the line down. Okay? That's the first step. Just write a prediction for the line for your best foot line. Looking at this line, I really want to see where it crosses the hash marks. Would be like right here. Yeah, so right there would be a good plot. So if you look, I just went rise over run. I went up 20. I know it's only one box, but it's 20 spots. And I went over 50. Which means if I go up here, I just went up another 20. Go over a little bit more than a 50. So I just want you to realize, though, we're doing our best that we can. It's not exact, but it's not bad for a best fit line. So write a prediction function. So I believe my function is the function of x is equal to my rise over run, which would be 20 over 50 x. And I started at the origin, so that would just be plus 0. That would reduce to the function of x is equal to 2 over 5. Now remember, this is not exact, it's about. And in math, when we're writing about, we don't draw straight lines, we draw these funny little squiggly lines. It's about 2/5. Okay? So that's what I want to use as my predictor. So basically for every 5 shots I take, I'm going to make, I'm going to make 2 shots for every 5 I take. So it says, what does the slope mean in the context? So remember, it's rise over run. So this is 2 shots made, 2 field goals made for 5 attempts. So if I were to write this in a sentence, for every 2 shot, how would I write this? I would make 2 shots for every 5 shots I take. Alright, so that's what it means in the context of this problem. So what does the y-intercept represent in this context? Right here, it's right here at 0, 0, and it just means if I get, so the point is 0, 0, that just means if I take 0 shots, I will score 0 points. That makes sense. If you don't take any shots, you're not going to get any points. So, use the prediction function to predict the number of field goals a person would make if he attempted 102 field goals. So it's basically saying, I'm taking 102 shots, how many points would I get? Well, just basically looking at this, I took 102 shots, it's right about 100. I would guess around 40-ish. Well, maybe a little bit more, a little less. But based off my line, it would be about 40. Remember, that means about 40. Let's actually use our equation now. So we have the function of, let's see, how many field goals would I make? So y is equal to 2 over 5 over 102. So now I'm going to multiply these together. I'm going to get y equals 204 over 5, which would be just over 40. So y would equal, I'm going to use the calculator really quickly, 204 divided by 5, and that means 40.5. excuse me, 40.8. Is it 5 or 8? 40.8. So that means I would score 40 baskets if I shot the ball 102 times. So really quickly, if you've noticed, my best fit line, it's a little lower than it probably should be. It could be a little higher, but that's why we say about, and that works for me. It's about 40 and 40.8. It looks maybe like 39.5 up here. They're all about the same number. So we're going to look at a new type of best fit line. So we're moving away from basketball. And when we get some of these, we might not know what a best fit line is because it looks, you got a lot of points and stuff. So we can use Desmos or other computer programs to actually draw us a best fit line giving us points. So it says software programs and graphing calculators can be used to draw lines of best fit. Zumi used a graphing calculator to generate a line of best fit for her data on the assists and rebounds. The graph to the right shows the line of best fit generated by a calculator. After creating this line of best fit, Zumi decided that it might be best to get rid of that outlier, to drop it. So the 3,26. So this one right here. She's like, this is messing up my data. So she wants to remove it from her data set because the data represents a player that joined the team midway through the season. That was one of the things we said. She could have been injured. She could have been many things. The player is actually new. So I have this line, and it's making this line getting pulled down to this point because it's a big outlier. So on this graph, here it shows it with the outlier. Here we removed it. We basically erased it, and I want you to notice the difference of the lines. This one's actually pulled up a little bit. So if I have this next slide, if I make it invisible, you can kind of see the other line. I did my best to stack the two images. When it looks like this, we got rid of the outlier. When I slide it over here, you can see that the line is pulled down. It's because that outlier, this point right here, is dragging that line down. So that's what I really want you to notice. So it says analyze the difference between the two lines. What did the outlier do to the best fit line? And what it did was it pulled it down. So hopefully that makes sense. If not, put a question mark there to show what I'm talking about. So I'm talking about this point is bringing this line down. If I erase that point, it is not pulling it down, and it would bring it more up. Okay? So let me make it so we can see both lines pretty well. And so it says analyze the difference. When you have an outlier, it brings / pulls the data in one direction. And that makes sense. Like, let's say we took the average of age in this classroom. We're all probably between the ages of 12, 13, and 14. So that would probably be the average around there somewhere. But let's say we included me. I'm 30 years old, and now all of a sudden the average is 17 years old. Well, that's the average because we included my age. But no one in this classroom is 17 years old. But my age pulled the average over there because I'm so old. So hopefully that helps with the idea of an outlier. Okay, so it says write a prediction line for the line of best fit generated by the calculator with the data set that does not include the outlier. So we're looking at this data now. There is no outlier, and I want us to determine what the equation of that line is. So what we would start is, let's go ahead and draw a best fit line, which is already there. And we want to start with this value, because that's my B value, and I want to see what that value is. So, and then I want to see if my slope is going down. So, it's really hard for me to tell when it looks like this, so I don't even want to try that. What I want to do is use points that are pretty close to the graph and see how that affects it. So if I were to use this, I would use the 2 points with probably like 50 and 100. So if I went to 50 and 100. You see how that is on the line? That's what we want to use. And we would go and to see if there's any other point on the line that is easy to tell. The next one would probably be about like 70 and 75. So it's not perfect, but it's pretty darn close. So I want you to notice that we're ignoring all the points and we're only focusing on the best fit line. So that means then I would go ahead and use those points of 50, 100. Remember, these are points on the line, not actual, not these black points here, but I just chose points that are physically on that line. And 70, 75. And I would want to find the change in y over change in x. So going from 75 to 100 would going up 25. Now we need to find the change in x. So when I go from 70 to 50, I'm actually going down 20. So that means I would have negative 5/4 as my slope. So then, to figure this out then, to figure out my y-intercept, I would just kind of look at my graph, and if this is like 175, this is 150, half of that is, let's see, 162, so it would look pretty close to like 175. But let's actually go ahead and find the slope by choosing these points. So, let's see, this would look like, I would choose 115 here. So it would say 100 is equal to negative 5/4 times 50 plus b. So when I solve this, I'll bring up a calculator. It would be 5 times 50 divided by 4. So that would be negative 62.5. So I have 100 is equal to negative 62.5 plus b. I would just add 62.5 to both sides to get 162.5 is equal to b. Therefore, my equation, now remember it's about, this is not exact, but it's about negative 5/4 x plus 162.5. Alright, so now let's go ahead. It says, what does the slope represent in this problem? So remember, it was negative 5/4. So remember, when one goes up, the other goes down. So when assist goes up, rebounds go down, or when rebounds go up, assists go down. So what this is saying, it's, remember, change in y over change in x. And what did we do? What did we do? So change in y. So when I get, for every 5 less rebounds I get, a person gets 4 more assists. So remember, 5 rebounds go down, 4 assists go up. If 4 assists go down, that means I'm going to get 5 more rebounds. What does the y-intercept represent in this context? It's basically saying if you get 0 assists, you're going to get 162.5 rebounds. So let's write that down. If you get 0 assists, you get 162 rebounds. Alright, use the function to predict the number of rebounds a random player would have to get if they made 110 assists throughout the season. 150 assists. Explain your reasoning. So I'm going to set this up and then I'm going to want you guys to solve. So remember, the total amount of assists is equal to negative 5/4 rebounds plus 162. So that means if I have 110 assists, it would look like this. This is for 110 assists. I'm going to stop the lesson right here and I want you to finish the rest by yourself. I want you to figure out number E and the rest of the problems.